For years, the U.S. Navy's Railgun was supposed to change everything. A weapon that could fire projectiles at hypersonic speeds using nothing but electromagnetic force. It looked unstoppable. And then, it disappeared. After more than a decade and $500 million, the program was quietly shelved. Most people assumed the Railgun was dead, another futuristic idea that never made it past testing. But recently, something changed. The Navy suddenly brought the weapon back, moved it across the country, and started firing it again at one of America's most advanced test ranges. So the question is, why now? Is the Railgun finally ready? Or is this the beginning of something much bigger? Let's find out. The U.S. Navy's Railgun program officially began in the mid-2000s as part of a bold push to revolutionize naval gunfire. The idea was simple on paper but revolutionary in practice. Use powerful electromagnets instead of gunpowder to accelerate projectiles to hypersonic speeds. No explosives in the rounds, no traditional propellant, just raw electromagnetic force slamming a projectile down two parallel rails at speeds up to Mach 7, more than 5,000 miles per hour. At that velocity, the kinetic energy alone turns even a small tungsten or aluminum projectile into a devastating weapon. A railgun round the size of a soda can could strike with the force of a cruise missile, but at a fraction of the cost. Early estimates put each round at around $25,000, compared to $1 to $2 million for a Tomahawk or SM-6 missile. And because there's no explosive warhead, the magazine depth is enormous. You could theoretically store hundreds or even thousands of rounds on a ship without the same safety risks as conventional munitions. The Navy poured roughly $500 million into the program over more than a decade. BAE Systems built the prototype gun. General Atomics worked on power systems and hypervelocity projectiles. Testing moved from Dahlgren, Virginia, to a dedicated land-based site. By 2016, the Railgun was firing live shots at its new terminal range, with dramatic videos released showing projectiles screaming downrange at hypersonic speeds. For a while, it looked like the future. Admirals talked openly about putting railguns on destroyers and eventually on next-generation surface combatants. The weapon promised to restore the Navy's long-range surface fire support capability that had been lost when battleships were retired. It could engage ships, land targets, aircraft, and even incoming missiles at ranges far beyond conventional guns. Then reality hit. The technical challenges proved brutal. The biggest killer was barrel wear. At Mach 7, the projectile generates insane friction and plasma. The rails literally eroded after just a handful of shots. Cooling systems struggled. Power requirements were enormous. The gun needed massive capacitor banks and energy storage that took up huge amounts of ship space. Integrating it onto an existing destroyer like a Zumwalt or Arleigh Burke became a nightmare. Costs skyrocketed. By the early 2020s, the Navy quietly shelved the operational program. In budget documents around 2021, officials said the hardware would be realigned to maximize its sustainability to facilitate potential future use. In plain English, put it in storage and stop throwing money at it for now. The Railgun wasn't dead, it was just paused. Many analysts assumed it would never see the light of day again. Fast forward to February 2025. According to official Naval Sea Systems Command, year in review documents and reporting from the war zone, the Navy conducted a 3-day live-fire test campaign with the exact same prototype railgun at White Sands Missile Range in New Mexico. The testing was a joint effort between the White Sands Detachment of NSWC Port Hueneme Division and the NSWC Dahlgren Division in Virginia. It was specifically conducted on behalf of NAVSEA's Joint Hypersonics Transition Office. The goal was to collect critical data on high-velocity firing, projectile acceleration, structural stresses on the rails, and overall system performance under extreme conditions. Photos released in the NAVSEA document show the massive prototype gun mounted on a test stand in the desert, firing once again. No public video was released this time, but the fact that the Navy bothered to move the gun across the country, set it up at one of America's premier missile ranges, and fire it under the banner of the Hypersonics Office tells you everything. This wasn't nostalgia. This was a deliberate resurrection tied directly to a new ship class. Enter the Trump-class battleships, officially designated BBG-X. These are planned 35,000-ton next-generation surface combatants, larger than current destroyers, designed from the keel up for heavy firepower. Construction on the lead ship, USS Defiant, isn't expected until the early 2030s, but the design already includes railguns as a core weapon system alongside hypersonic missiles, 5-inch guns, and directed energy lasers. The railgun fits perfectly into this new vision. It gives the ship a deep magazine of cheap, high-speed rounds that can engage surface ships, land targets, and even aerial threats at long range. In a Pacific fight against China, where missile inventories could be exhausted in days, a railgun-equipped battleship could keep firing for weeks. But the challenges remain real. Barrel life is still measured in dozens of shots rather than thousands. Power and cooling requirements are massive. Future ships will need dedicated reactors or advanced energy storage. And integrating the system without turning the ship into a floating electromagnetic interference nightmare is no small feat. That's why the revival is so significant. The Trump-class battleships are being designed with these problems in mind from day one. Larger hulls mean more room for capacitors, cooling systems, and reinforced structures. Newer materials and manufacturing techniques could dramatically improve barrel life. Meanwhile, international efforts have continued to advance, with Japan emerging as a leader in naval railgun development. Japan's Acquisition, Technology, and Logistics Agency has pursued the technology steadily since launching full-scale research in 2016. They achieved a global first in October 2023 with the initial shipboard firing test from an unspecified platform. By April 2025, the Japan Maritime Self-Defense Force publicly released images of a prototype railgun turret installed aboard the experimental test ship JS Asuka, a 6,200-ton vessel dedicated to advanced technology trials. The program reached a major milestone in the summer of 2025. Between June and early July, ATLA conducted live-fire tests from the JS Asuka against a real target vessel, a tug-like ship towed for mobility during some shots. ATLA announced the trials as the first successful ship-mounted railgun firings at an actual target ship in history. Projectiles struck the moving target at long range, yielding valuable data on accuracy, impact effects, and system performance in real sea conditions. Engineers reported overcoming key hurdles, including sustaining over 120 consecutive rounds without catastrophic barrel failure in related ground tests, demonstrating progress on durability that eluded earlier programs. Japan has benefited from international cooperation, including a formal agreement with the Franco-German Research Institute of St. Louis for railgun-related R&D. In 2024, Japanese officials met with U.S. Navy representatives to discuss sharing insights from America's earlier extensive testing and research, potentially paving the way for future technical exchanges. Ongoing collaboration with partners has helped accelerate solutions to challenges like power management and thermal control. The data gathered will most likely also help the United States in developing its own program. Other countries have also been pursuing railguns, particularly for naval use. A prototype railgun mounted in a large turret notably appeared on a People's Liberation Army Navy ship in 2018, though the exact status of that program is now unclear. There has also been a very public naval railgun development program underway in Turkey in recent years. If nothing else, the February 2025 tests at White Sands were the first public signal that the Navy is serious about making this happen. The gun still works. The basic technology is still viable. And now there's a clear path to ship integration on a new hull class that has the space, power generation, and cooling capacity the older destroyers never had. And what do you think about this? Share your thoughts in the comments below. And if you enjoyed the video, don't forget to like it, subscribe to the channel, and turn on the notifications to always stay in touch. See you soon!